video. So make sure you have your notebook and ready to take notes. All right, so you already learned a little bit about exponential functions. And so today we're going to be able to write exponential functions. And then we're also going to be able to use technology, which is Desmos, to be able to write functions. All right. And so the first thing you have to be able to do is you need to be able to evaluate any type of function. And so remember, when we evaluate, that just means plug it in, or you can use a table as a tool. And so that's what I'm going to do. I'm going to use Desmos to help me answer these problems. And so I'm going to go ahead and type in f of x is equal to 2 to the power of x. And then I want to turn that to a table. So you hit the cog and then table, and then you simply go down, and it wants to know when x is equal to 10, and it tells you it's 1024. Okay, so we can evaluate these very easily using Desmos. It's pretty simple. Just plug it in and see. So go ahead and try the next one on your own. Make sure you're able to do it. So pause the video, try it, and then you come check. So if you tried it, then what you would have done is went in here and typed in, this one is going to be 3 times 0.5, all raised to the power of x. And then in your table, you want to find out when x is 7. So I could just type in 7, and it tells you that it's 0.023. It keeps going. But basically, all you need to do on that is just round to 2 decimal places, so it's 0.02. So when x is 7, y is 0.02. Okay, great. Now, for the next one, it says, what is f of x equal to 3 to the power of x if f of x is 243? And so the first two, they would give you x and to ask you to find y. Now they're giving you y and asking you to find x. And so the easiest way to do this one is pretty much the same thing, except we get rid of that. It's f of x equal 3x, and I want to find 243. I don't want to play the guess and check game here. And so what I'm going to do is go all the way across to where y is equal to 243. And I'm going to zoom in on that. And so here's 243. And if I click on my graph, I can see that the answer is 5. And so as long as you can read, like we've talked about all year, which one of these is x, which one is y, x is on the inside, y is on the outside, you'll be able to answer that question very easily. Okay, great. All right, now it says, for these real world problems, it says the number of students at a high school is 600. It increases at a rate of 3% per year. And then it says, gives you the equation that basically f of x equals 600. That's where it started. And the 3% rate of growth, where x is in time years. Find the population after 4 years. For these type of questions, you just want to use Desmos every time. And so I'm going to go in, I'm going to type in 600 times 1.03, all raised to the power of x. And then you want to find after 4 years, you can simply just go to one line, type 4, and it will tell you what that population is. And so it was 600, but after 4 years, it's 675.31 would be the answer to that. Okay, so, pretty simple. Most of the time, they're going to give you the function on exponential, throw it in there, be able to use the table and the graph to answer your questions. Okay, the next one says the number of subscribers to a web service is represented by this equation, y equals 20 times 2 to the power of x, where x represents the time in months. So they're telling you how many months, they're telling you what the x is. You just need to go find out how many subscribers they would have. And so once again, you would want to go into Desmos, type in your equation, 20 times 2 to the power of x, and they want to know after 5 months. And so remember, any line I can type in the 5, I'd have 640 subscribers. Now the next question says, how many months will it take to have 2,560? And so remember, there's an x and a y. They're going to give you one, you got to find the other one. And this part A, they gave you the x and to ask you to find the y. On the bottom part, they're giving you the y and asking you to find the x. So we need to find out when y is 2560, what is x? And so let me enlarge this. I'm going to use the graph for that because it's easier. So when y is 2560, when y is 2560, so I'm going to have to go way up. So I'm going to zoom in so I can go faster. And I'm going to go up to 2560. So here's 25. I'm going to start zooming in on that. I want to get into 2560. So 2560 is right here. I click on my graph, and it is telling me that it is 7. It would take 7 years to get to 2560. And so Desmos makes this very simple to be able to answer these questions. One Why don't you try now? This one they did not give you an equation, and so now you have to write the equation, and so that makes it a little bit more difficult. But it says a prescription drug has a half-life of 1 day. If a person takes one-time dose of 30 milligrams, how much of the drug is left in the body after 3 days? And it wants to write the equation with B as 1/2 for the half-life. All right, so on this one, you would need to write the equation as y equals a times b to the x. And so you would write y is equal to, what do we start with? We start with 30. So that's going to be y is equal, don't need that, need this. And so you're going to write y is equal to, and we're going to start with 30 because that's my A. And then that's going to be times my half-life. So half-life is 0.5, right? So 0.5, and that's to the power of x. So you're literally just going in and talking about where you start and then your rate of growth or decay, in this case, your rate of decay. And so that's how you would write the equation of that. Now, it wants to know after 3 days, where are you going to be? And so all I need to do is go over to Desmos and type it in, 30, and then times 0.5 to the power of x. And then after 3 days, it would be at 3.75. So it goes down pretty fast, right? So 3.75. All right, good. And then these type of problems, when you have interest rates and things, it works the same way. And so it says Larry invests $4,000. You're going to put that, this is a formula for principal, but it really is just an exponential function. And so you're going to get y is equal to 4,000. Okay, times, and then you're going to do 1 plus the rate. Well, the rate is 5%. 5% is 0.05. And so when I do 1 plus 0.05, I get 1.05. So in the parentheses, it's 1.05 to the power of x. All right, so that's the function that you would write to describe the situation. Now, how much money will he have in the account after 3 years? Once again, you got to use Desmos for that. And so I'm going to go in and type in 4,000, and I'm going to do 1.05 to the power of x. And then after, it said 3 years, we would have 4,630.5. Okay. Now, I want to know how long it would take to have 5,628.40, right? So in this case, I'm going to go to 5,628.40. It means I have to go to Desmos, and I'm going to look on the graph. I'm going to go up here to 5,628.40. So there's 500, 620. You got to keep going. 25, 26, 27, 28. So it's going to be right in here. 526, 8.40. So it'd be 7 years, right? And so remember, if they ask you if they give you the y and ask you for the x, you can use a graph. If they give you the x and ask you for the y, you can use the table. All right, good. And then now that takes care of real world problems. Now let's talk about whether sequences are arithmetic or geometric. So we talked about arithmetic sequences when we did linear equations. And we know that an arithmetic sequence, all that is just a linear equation. Well, a geometric sequence is going to be an exponential equation. Okay, so let's look at a few and see what we can find out. And so, and remember, we already talked about that. So arithmetic, remember, increases by adding or subtracting. So like in this case, I'm adding 6 each time, right? In this case, I'm subtracting 5 each time. A geometric sequence is by multiplying or dividing. So you can see how this is going up pretty steadily. It's going, my pointer. This one is going up by 6, up by 6, up by 6, up by 6. Down by 5, down by 5, down by 5, down by 5. This one, look how fast it's increasing. It went from 2 to 10 to 50 to 250. Okay, so 2 times 5 is 10. 10 times 5 is 50. 50 times 5 is 250. That is an example of a geometric sequence. All right, so let's look at this, and you tell me if you think this is an arithmetic or a geometric sequence. And so what we're going to need to do is we're going to need to figure out what it's changing by. So if I go from 5 to 10, Either I'm going up by 5 or I'm multiplying by 2, right? So if I'm going up by 5 or I'm multiplying by 2, I don't know which one. What's happening to the next series? I'm going up by 5. I'm going up by 5. I'm going up by 5. That is an example of an arithmetic sequence. Okay, this one. I went from 1 to 1 to 2 to 3 to 5 to 8 to 13 to 21. Well, this one I'm going up by 0. This one I'm going up by 1. This one I'm going up by 2. This one I'm going, 2. This one I'm going up by 2. This one I'm going up by 3. This one I'm going up by 5. This is not a steady pattern, and it's not growing very quickly. So this one would be an example of neither. Okay, now this one, I'm multiplying by -4. Multiplying by -4. Multiplying by -4. Multiplying by -4. So if I'm multiplying by -4, that's an example of a geometric sequence. Because look how fast it's increasing, right? It's times 4 from the previous answer, so it's going to grow very quickly. Okay, and then even when you go backwards, it works the same way. Here I'm going to be dividing by 2. Here I'm dividing by 2, dividing by 2, dividing by 2. So it's going down very quickly. So that's a geometric sequence. So you got to be able to study these and look at the patterns and know what's happening to those problems. One thing that might be able to help you is that you could turn these into a table. Now you would need to put all the points in, but you could literally make this be a table that is the point 1, 5, 210, 315, 420. Put those in and see what type of graph it makes. If it makes a straight line, it's arithmetic. If it makes a exponential, like we've been studying, then you know it's geometric. If it makes neither, then you know that it's neither. Okay, so that is it for arithmetic sequences. For geometric sequences and for exponential functions. We're going to have an M&M activity next class, and so you'll need supplies for that. I've already sent an email out to your parents. If you're not able to get those supplies, please reach out to me because I want you to be able to experience this activity. Make sure you do the practice, do the star checkout, the ticket out the door, and then be ready for that activity next time as well as the quiz. Okay, you guys have a great day. Bye.